Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about Bayes' theorem, and this theorem is useful and is derived from the definition of conditional probability. So this is the formula, the Bayes formula, and I'm going to show you how can we derive that from the definition of this one here. So we've got conditional probability. For example, let's consider this one, A, probability of A given B. And we all know how to find this conditional probability. What you have to do is you need to find the intersection. On the top part here is the intersection between A and B. And since B has already occurred, we can supply the information right here. So we've got probability of B to be somewhere here. And I'm going to call this equation 1. Right, next let's imagine we have another conditional probability somehow flipped or switched. We can consider having conditional probability of B given A. So in this case, how do we find this conditional probability? Well, again, we need to find what's the intersection between B and A. So here we have intersection of B and A, and again here A has already happened. So A has already happened, and we will know what's the probability of that, and we're going to supply it right here at the bottom. And for your information, this part here is probability of B intersects with A is the same thing as saying probability of A intersects with B. Okay, right, and this is going to be the second equation. Well, I hope you can see that based on this equation here, we can find what is A intersect with B. What is the probability of A intersects with B? So this part, what is it? It is just multiplying BA with B given A. So we're just playing around with this equation right here. And I'm going to call this 3, and 3 is going to be supplied to 1. So we're going to substitute 3 into 1. Okay, we're going to substitute the results here into equation 1. Therefore, what we have is probability of A given B is going to be equal to, so we are going to substitute that into this. So we have BA, B given A, and we have PB at the bottom. And this is how we got this formula given here. So at first glance, it might look like a bit confusing, because really they look like we're having the same formula. So basically the idea is like this. The idea is you want to find this one, you want to find what's the answer to this conditional probability, but for some reason you only have to work, or you have only the flipped probability, where you have the event is somehow being switched. You have B given A, so you need to work on that and make sure with this information you will get to find what's this probability given here. And perhaps this idea is better illustrated if you look at the example given here. So here is an example of 2.18. Joe is a randomly chosen member of a large population in which 3% are heroin users. A particular drug test correctly identifies users 95% of the time and correctly identifies non-users 90% of the time. So what is the probability that Joe is a heroin user given that his test is positive? All right, perhaps we can try and write down some of the information first. So here we've got probability the person is a heroin user. So probability heroin users is 3%, which is 0.03. Next, test correctly identifies users. So I'm going to write down this whole sentence. What is the probability? Test correctly identifies users. So this is 0.95. Now, based on this statement here, we can come up with our information, where we can say that probability test not correctly, okay, so this one is correctly, this one is not correctly, identifies users. So clearly that this one is the complementary event for this one. So 1 minus 0.95 is 0.05. So this is the information that we can derive from this information given here. Now, if we continue with the next statement, this is the probability that the test correctly identifies non-users. So probability test correctly identifies non-users. Okay, and this is going to be 90%, which is 0.9. And based on this statement given here, we can derive another probability, which is probability that the test not correctly identifies non-users. And this is going to be a complementary event to this one. Therefore, the probability is 0.1. So I hope you can see slight differences in the events of interest. For example, this one is related to correctly identifies users. So here is the complementary event to that, which is not correctly identifies users. Now we move on to the next event. This is about correctly identifies non-users, and the complementary event to that is not correctly identifies non-users. So we're talking about this one is non-users, this one is users. So what is the question asking us to do? So if I write down the question is asking to find what's the probability Joe is a heroin user given that his test is positive. So this part here is an event that is already known. So probability Joe is a heroin user given that the test is positive. The test is positive. Now, in order to answer this question, we are going to have to how do I say this, adjust some information that we have already got here. For example, now I'm going to do some sort of adjustment, slight adjustment. For example, here, when the test correctly identifies users, what it means by that? When the test correctly identifies users, this is actually probability of you get a positive result given that you know the person is a heroin user. So this is you get a positive result, test positive, given that the person is a user, heroin user. So this is actually what it means by these original sentences here. So these original sentences here, we can write down in terms of this one. Okay, so what about this one? Test not correctly identifies users. In other words, it means probability the test is negative, given that the person is heroin user. The person could be a heroin user, but the test cannot detect that person being a heroin user, so the result here is going to be negative. Right, next is this one. This is test correctly identifies non-users, which means that if it correctly identifies non-users, the result is going to be negative. So the test is going to be negative because the person is non-users, not heroin user. Okay, so you can see that the result is going to be negative. Then that is how it correctly identifies non-users. And this one, the test not correctly identifies non-users. So we know that here the result is going to be positive. The result is going to be positive. It cannot correctly identify non-users, so it will give a positive result for the person that is not a heroin user. It can be a bit daunting, but think about it like this. Think about it like in a situation where, for example, you are pregnant and you do a pregnancy test. The pregnancy test could give you the correct result or the wrong result. For example, it could tell you that if you are pregnant, the test might not be able to tell you the correct result. It might tell you that you are not pregnant, and stuff like that. So I think that's the scenario that you can think of when you consider this idea of drug testing. So for example, the person could be using the drug, but the test cannot give you the correct result. The test somehow is flawed and said that the person is not a heroin user when he actually is. But a good test will have a small probability for that case. So here the probability is small, 0.05, but there is like 5% chance of saying the person is not a heroin user when it is in fact a heroin user. And similarly, when that person is not a heroin user, we expect the test to give you a negative result because that person is not using drug, so the result should be negative. And you can see that this is a high probability of getting the correct identification. But there's also a small probability here where the test might say the person is positive when he actually is not a heroin user. So this is the mistake that could happen when you do drug testing. So this is a probability of making a mistake. This is also a probability of making a mistake. Okay. So I hope you can see from this slight modification that what we want is this probability, this conditional probability of the person being a heroin user given the test is positive. But what information we have is the other way around. We have a test positive, heroin user at the end of it, test negative, not heroin user, and stuff like that. So this is a bit of a flipped condition or flip scenario, which I have already demonstrated here. For example, this is what we want. We want A given B, but what information we have is the other way around, which is the probability of B given A, as what I have demonstrated in this part here. You can see that this is what we want. We want something like A given B, but the information we have is somehow flipped. We have B given A, for example. Okay, so we need to be able to use this information in order to answer this question. Okay, I don't have a proper space, so I've got to erase this part. Okay, I'm just going to erase I don't know where to erase. Okay, maybe I'll just add another slide, another new slide. Hang on. Okay, I'm just going to add new blank space over here. Okay, let's continue our discussion. Right, like I've told you many times, the idea is to actually visualize the process or the question using a tree diagram, because then you can see things clearly. And this could be one way of doing it. Okay, so these are all the informations that we've got so far, and we're going to consider this part where in the population you could be a heroin user, or you are not heroin user, and the probability of the person being a heroin user is 0.03 as given in this part. And so since this is a complementary event, you are not a heroin user, so this is heroin user, and this one is not heroin user. So the probability is going to be 0.97. Okay, you add them up, it should be equal to 1. Next, we've got the result, the next situation, where if you are a heroin user, the result can be positive. If you are a heroin user, the result of the test can also be negative. So there will be two possible situations when you test a heroin user. So when you are a heroin user, given that you are a heroin user, the positive result here is going to have probability of 0.95. Okay, 0.95, right? So here is 0.95. But somehow the test might make some mistakes. For example, you are a heroin user, but the test gives you a negative result, and the probability here is small. It is just 0.05. Okay, in a similar manner, we can see that if you do a drug testing on a person that is not a heroin user, again, there are two possibilities. You can get a positive result, you can get a negative result. Now, the result that we have here, you test negative, given that you are not a heroin user, is 0.9. This is what should happen. If you're not a heroin user, the result should be negative, right? And the probability of getting a negative result should be high, and in this case it is 0.9. So if you're not a heroin user, then given that you are not a heroin user, the result is negative. The probability of that is 0.9. But sometimes, like I said, the drug testing can make mistakes. So if you're not a heroin user, there are also a small chance of probability that the result is going to be positive, and that is just a small probability, which is 0.1. And basically that's what's going on with our problem right here. So we have managed to visualize our problem in terms of a tree diagram. Now the question is asking us to find what's the probability the person is a heroin user given the test is positive. And I can write it in terms of probability of H given the test is positive. And this is a base problem because what we want is this one, okay, but what we have as our information is the other way around. For example, 0.95 here, what is the meaning of 0.95? 0.95 here is the probability that the test is positive given the person is a heroin user. So you can see that this is what we want to find out, but the information is given the other way around. It is P given H. Okay, excuse me. So now we're going to apply base formula which says that if you want to find the probability of H given P, it will be finding P given H times with probability of H over probability of P. Now, how do I get this formula? Well, I just consider this formula given here. So this is base formula, and what I did was just like changing the alphabets accordingly. Okay. If you find it difficult to grasp, just try and do it slowly. Okay, you may want to pause the video or repeat parts that you find it difficult to understand. Okay, so this is what happened now. So this is applying base formula. Okay, and what is the probability of P given H times PH? So this part, so this is probability of P given H, which is this one, times PH. So this is the probability of H. Probability of that person is a heroin user. So I'm just going to plug in these two values. So it will be 0.95 times 0.03. Okay. Next, I'm going to find what is the probability of getting positive result. So P here is getting a positive result. Now, if you look at this tree diagram here, you need to identify the path where the result is positive. For example, this is the positive result and this is the positive result. So this is the first path that we need to consider, and this is the second path that we need to consider because the result here is positive. We want to find the probability of getting a positive result. And we know that in order to find what's this probability of the first path here, it will be just multiplying the probabilities given. So for this one, the probability is going to be 0.03 times 0.95. And for this one, the probability is going to be 0.97 times 0.1. So 0.97 times 0.1. So if you add them up, you will get the probability of the result being positive. Okay, so you add these two probabilities and this is what you will get. This is what you're looking for. So that's what I'm going to do. I'm going to write down the process here. We're going to multiply 0.03 times 0.95 plus, okay, we're going to plus this result, which is 0.97 times 0.1. And punch in the numbers into your calculator. You'll be able to get that the answer to this question is 0.2271 if you are using 4 decimal places. Okay, I think that's all for now, related to, some simple idea of base theorem, base formula, and example of that. Thank you very much for watching.